This will be the Algebra 2 sample video for Unit 2. It's new for 2017, 2018. New questions, couple new approaches, okay, from the old video. All right, so what you want to do here, all right, we're going to start with H. So what you're going to do with these, this is composition. So this is what you start with, okay? So you're going to take the H function and you're going to remove all of the x's to start. Notice how that 2x, the x went away. Now this is what you fill in, this function, all right? So I'm going to fill in x squared minus x. Now, when this is x, you're going to either do some distributing, multiply, you might combine some like terms, that kind of stuff. Okay? 2x squared minus 2x minus 1, I cannot combine anything. Okay? I'm going to stay with this problem, that way we don't have to scroll back. Okay? For 5, I'm going to start with the g function. So notice, the x squared became a blank with a squared. The minus x became a blank, so you remove all the x's. Then I'm going to fill in the f function, which is 4x plus 7, into this. Now, when you have a number, this is different. You're going to store that number for x, okay, and then you type in your function. All right, so here's what I mean by that. I'm going to hit 2, then this little arrow here, then x from here, then execute. Now I'm just going to type that in. 4x plus 7 squared minus 4x plus 7. And I get a numerical result of 210. Okay? So if you get a number, it's going to end with a number answer. Letter answer. Okay? H of x, okay? H will be 2x minus 1. Okay, so I'm going to start with 2 blank minus 1. I'm going to fill in the f function, which would be 4x plus 7. Okay? All right? Now, go ahead and, even though it's got a 5 in there, we're still going to distribute this. That's going to be 8x plus 14 minus 1. If I combine this and this, that's 8x minus 13. Now, with the 5m, all we're going to do is we're going to put 5m right here. So that turns into 40m minus 13. And that's the final answer. So if it's got a variable, it's got to have one in your answer. H of x, all right, once again, h is 2x minus 1. H of h, so 2 space minus 1. I'm filling in the 2x minus 1. Now, because it's got an x, I'm going to distribute. That's 4x minus 2 minus 1. These combine, 4x minus 3. Okay? G of k of x, g is going to be x squared minus x. K is going to be square root of x plus 3. Okay? The squared eliminates that. That's x plus 3. This just will stay like this, and that cannot combine. Okay? Let's just stay with this g of g. Okay? So I got g, which is this, minus this. And I'm going to fill in g, which is x squared minus x squared minus x. Once again, what I want to do is I want to use my number. So I got a -4, arrow, x, and all I'm typing in is exactly what I see. I don't overcomplicate it. Okay? Whoops, I almost forgot the squared, almost made a mistake. Minus x squared minus x. Okay? And I get an answer of 380. Okay? Let's scroll up and do these last two. F of g of 3. So I'm going to start with f, which is 4 plus 7. I just removed the x. I'm going to fill in that g function. Because it's got 3 arrow alpha x, or sorry, 3 arrow x, then 4 x squared minus x plus 7, 31. Okay? H of g of x, h will be 2x minus 1. We're going to fill in g here. G is x squared. Oh, it's the same problem. This is just the same as this one, okay? So it's the same thing. Sorry for the repeat. All right? So it's a repeat. Okay? Same thing as the other one, okay? All right? So that's that. All right, let's go to the next one. Okay? So these are a little bit new this year. All right? Finding compositions. All right? F of g of 3. So this is where you have to look at this a little bit differently. This is really written like this. So what it means is, if you get these mappings, that you should find g of 3 first. Okay, so g of 3 leads to 2. Okay, so then what I have is f of 2. So this is 2 leads to 5. So that will be 5 for my answer. G of f of 6, we're going to start with that. F of 6, all right, that would lead to 1, all right? And then I take that, so now I got g of 1. G of 1 will lead to 4. Explain why g of 2 does not exist. G of 2 does not exist. Let me remove this. Because if I do g of 2, okay, so I would start here. G of 2 leads to 5. But then when I go over here, there is no 5. So the answer is there is no f of 5. Okay? All right, so start from that inside. All right? Solve these algebraically. Okay? Now, here's my recommendation. For inverses, this is a common thing. Oops. All right? Inverses. What you want to do is you want to find the inverse function. Now, whatever is outside goes inside and changes sign. Okay, that's how you find an inverse. All right. Now, for a line, all right, for a line, the inverse for a line is just x. Okay, is just x. All right. To make this easy, this plus 5 would be outside. So now it's going to be inside and become negative. All right, now, here's what I would recommend doing. This is multiplication outside. Okay? The opposite would be divided by the inside. Okay? So I got f of x equals 1/4 x minus 5/4, because you divide them. The other alternative to that for lines, and you might want to just do this with lines, is to switch the x and y and to solve for y. Sometimes that, oops, that should be, hold on, that should be a minus 5. Minus 5, so I got x minus 5 equals 4y, and divide by 4, and that would lead to that result. Sometimes, this might be the one exception where you don't want to use this pattern, because the line can be sometimes complicated. Now, with x squared, that's pretty obvious. The inverse, and this is what the symbol is for inverse, I should have used it up here. The inverse sign of squared is square root. This 1 is outside, so I'm going to remove that inside, it becomes minus. Okay? Let's go on to these other ones. Square root, same thing. G of inverse, that's going to become, the square root's going to become x squared. That minus 3 is inside, so that becomes plus 3 on the outside. That's plus 4 on the outside, minus 4 on the inside. Okay? This, all right, would turn into the inverse would be squared. Okay? That's 5 on the outside, that becomes minus 5 on the inside. Now this is 2 times the outside. So the opposite of that would be 2 divided by the inside. So that's what you have there. Okay? Now, exponentials and logs. This is a little bit different. Your inverse function, log, let's say of 7, an exponential base of 7. That's how you convert from one to the other, okay? All right, so what I would have, all right, is 7 to the x. This would be outside. So this right here now would be minus 3 is considered the inside. So when you have inside the function there, that's what you have. When you don't have a base, you can use 10. So what this would be base of 10, okay, with an x here. Now, this minus 5 is on the inside, so that's going to be plus 5 on the outside. This would be times 2, 2 times on the inside. That's the answer there. Times 2 on the inside, so that would be divided by 2 on the outside, and that's what you would have. Okay. Okay. Here, now I'm going to change this to a log. The inverse would be log base 6 with x. This is plus 1 on the inside, so we do minus 1 on the outside. Okay, this would be log base of 3. All right, this would be minus 2 on the inside, so plus 2 on the outside. This would be plus 7 on the outside. This would be minus 7 on the inside. Okay, all right, given this, determine if they're inverses. What you would do is you would do f of g of x. Okay, so what would happen here is you would start with the f function. All right, leave this blank, squared plus 3. All right, and if you put this in, the square root of x plus 2 minus 3, what would happen, okay, is that this would not cancel out, so this would be no. All right. This one, all right, very simply, this would turn into, if you did composition, f of g of x. We start with f. We put g. Okay, this would be 1x. If you distribute that, 3 times negative 4/3 is negative 4 plus 4. That's going to be 1x, which is what we want. And you can verify the same thing, all right, either way. All right, which ones are true or false? Okay, the x and the y flip. This would be true. The reflection across x is they're true. This is false. This is, all right, because they're not always. Okay, this would have had to have been positive x, so this would be false. Okay. The last thing here is the domain. All right, this is going to be false as well. All right, if the domain of this is this, then what this should say is the range would be y is greater than or equal to 3. Because the idea behind the inverses is the x and the y split. Okay, question 21. Okay, what you have to do on this, all right, if you look at these points, all right, that's 0, negative 2. So when you have the function and its inverse, if this is 0, negative 2, this should be negative 2, 0. So that means we should have a line going through negative 2, 0, which we don't. So that would be no, because this one doesn't pass through negative 2, 0. Okay, similarly here, what I would do, that's 1, 2, 3, 4. That's 4, negative 1. That's 0, 1. So all I would do, and that's also 3, 0. So what you would do to get the inverse, I'll graph the inverse in red. The inverse would have to be 1, 0, 0, 3, and negative 4, negative 1, 4. So 1, 0 would be here, okay? Negative 1, 4, 1, 2, 3, and 4. All right. Whoops, that's not right. Sorry. Negative 1 over 1, 2, 3, and 4. And then 0, 3. Okay. And so what would happen here is that this would look like this. Okay. All right. It would, instead of the anchor point being 4, negative 1, it's negative 1, 4. Instead of the next point being 1, 0, so it would look like something like that. Okay? All right, 22. All right, this should have just been 6, because when you do the inverse of x, it's got to stay x. Okay? Graph this, label them on the same axis. What I would do, pretty simple, is I use a table. I would put 2x plus 4. All right, and you can plot whatever points you want. You want to use 0, 0, 4, 1, 2, 3, and 4. Okay, you want to do 1, 1, 6. All right, and then 2, 8. All right, negative 1, 2, and negative 2, I think it's 0. All right, so the idea here is if you look at, this is that one, okay? So what points did I have? I had negative 2, 0. I had negative 1, 2. I had 0, 4. I had 1, 6. I had 2, 8. So what the inverse should be, 0, negative 2, 2, negative 1, 4, 0, 6, 1, 8, 2. Okay? So I'm going to graph that in blue. All right? So 0, negative 2, 2, negative 1, whoops, sorry. 2, negative 1, 4, 0, 6, 1, 8, 2. All right, that's what it'll look like. All right, I think I've done 24 already. Yep. Okay. All right, rewrite the log in exponential form. Pretty simple. When you do a simple conversion, all right, this is still the base. All right, and these move. So that's 2, 289. Same thing here. This would be the base. Negative 3 would be up here. This would be 1 over 125. Okay? All right? So the base of the log would still be y. 144 comes over. X is over here. This base would be 196. The 1 over 114, negative 1/2. So basically, the things switch. I couldn't get any easier than that. All right, now, so this next part. All right? I'm going to use the TI. Okay, I'm going to try to show you this to the best of my ability with the graph, because there's a feature here that you can use to graph. All right. So the anchor point with something like this will be 0, 0. Now the idea with our anchor point, this is something you want to write down. If it's an exponential, all right, you're going to have an asymptote where y equals 0. Okay, and it will be horizontal. All right, whatever the y coordinate is the asymptote. So what I got is it would look like this. Okay, and so when I go into the graph, just like I normally would, all right, I want to graph 1, 2, negative 1, negative 2. All right, 2 points to the right, 2 points to the left. All right, so I'm going to go 3 to the x. All right, table, I'm going to graph 1, so that's 1, 3. And I'm going to graph 2, which is 2, 9. Then I'm going to graph negative 1, which is like 0.3. And then I'm going to graph negative 2, which is like, it's almost touching it. Not quite. So what my graph looks like, hits those points, goes right up through. Okay, for log, I've got a vertical asymptote. That is x equals. Now, my anchor point here is 0, 0. That's why that one matches. So our vertical asymptote goes this way. Okay? Now, all right, what you want to do, and I'm going to see if I can show you this. Okay? I'm going to see if I can stand behind the screen. Okay? So what you're going to want to do with this is you're going to want to go to the graph. All right, I know this is not going to zoom that great. You're going to want to go to Calc, which is F2, And if you notice over here, there's a log deal. Okay, if you hit the log AB, that gives you that. So you put 2 there and X there. Okay? Actually, you want to go into a table. I'm sorry. So go to menu, find table. All right? So what you want to do is let's delete this so I can show you again. All right? So what you're going to want to do there is you go to option. Okay? So go to option, then to calc. All right? And then to the log AB button. All right? And what you do is do 2 and X. All right? In the table. What I want to graph here, very similarly, -1 and -2. So if I type in 1, I get 0. If I type in 2, I get 1. If I type in -1, I get an error. Okay. So what that means is, okay, this graph will be going like this. Okay. All right. You might want to graph an extra point here. All right, just to be honest with you, you might want to try graphing 3. All right, 3 is like 1.5, just so you can get another one. All right, if you want to continue that out. My big thing is making sure you have the correct shape. All right, let's scroll down here. All right. So what I got here is my anchor point is 1, 0. Okay, since it's an exponential, I know it's got to be a y equals. So y equals 0 would put me there, all right, through my anchor point, okay? All right, and also what I want to graph here though, all right, I'm at 1, so I want to graph 2 and 3, let's say 0 and -1. All right, I can do the exponentials in this calculator. All right, so 2 exponent x minus 1. All right, so I want to graph 2, that's 2, 2. I want to graph 3, it's 3, 4. I want to graph 0, which is at 0.5. And I want to graph -1, which is at 0.25. Okay? Over here, my anchor point will be -2, 4. Okay, so 1, 2, 1, 2, 3, and 4. So I will draw a vertical one through here. Okay, and it's the same deal. You want to go into the table and go to option, then calc, which is F2, and then log AB, which is F4. Okay? And you can put in your 3, you can put in your x plus 2, you can put in your plus 4. Okay? Now, what I want to graph in this, if I'm at -2, I want to graph -1 and 0, or try to, and -3 and -4. Alright? Now, you can start with this. If I try to put -4, this doesn't work. It's like the square root button. -3 doesn't work. Alright? You might want to continue and graph maybe 1, just to give yourself a shape. But I'm at -1, 4 up. Then 0, which is 4.6. And then 2, which is like 5 point something. So what that's going to look like, it'll look like that. If you wanted to graph another one, you could see that on there as well. You could keep going till you had, if you got like, I think, if you keep going, 5, 6, 7. If you graph 7 over, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, that would work as well. Okay, so you can, the bottom line is, you got to know these shapes. Okay, you got to know the shapes. Okay, 33. All right, so what my anchor point here would be 0, 9. Okay, I would have 0, 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got this that goes through. All right, that's a y equals 9 based equation. Okay, so when I go into the table, all right, I go -3 to the x, okay, plus 9. Okay, all right, since I'm at 0, I would graph 1 and 2. All right, -1, -2. All right, so I'm going to try 1, 1, 6. I'm going to try 2. It's 2, 0. I'm going to try, maybe I should grab 0. 0 would be 0, 8. Okay, negative 1. It's this right here. And then negative 2 will be close to this as well. So what this graph looks like is this. Okay? Now, what you want to do when we find this stuff is label your arrows. Well, one of these is y equals 9. If you see this is approaching, this arrow will have a coordinate of 9 because this approaches 9. Now, this will still be a left arrow at negative infinity. This will still be a right arrow where it's going down at negative. But one of these arrows is going to have that asymptote in it. Okay? So let's see if we can find some of this stuff here. Okay? So my zeros, x equals 2. Same thing here. My y-intercept was y equals negative 8. My vertical asymptote, I didn't have one. My horizontal asymptote was y equals negative 9, or positive 9. Okay, oh, my y-intercept was positive 8, I'm sorry. Okay. Increasing degree, decreasing. So this starts here. If I trace, that's decreasing the whole way. So this is going to be none. This will be from negative infinity to infinity. End behaviors, okay? As x approaches infinity, which will be that, the y is negative infinity. Okay? As x approaches negative infinity, my y-coordinate is 9. The domain, the smallest x value, is negative infinity. Biggest is positive. Okay, so my domain would be all real numbers, XER. Okay, for the range, the smallest y value I have is negative infinity. Biggest is 9. So that's a scenario like this where it goes this way. All right, so now, since this is an asymptote, this is going to be y is less than 9 because it's in a dashed line. Okay? Let's go to this one. All right, once again, my anchor point would be negative 3, negative 2. 1, 2, 3, 1, 2. So it goes like this. That would be an x equals negative 3. Okay? You want to go into that area of your calculator to put in the log. All right? And what I want to do is let's go ahead and graph negative 3, negative 4, negative 2, negative 1. This would be negative 4 and negative 5. Okay? I think if these two, if you type these in, you don't get anything. So let's type in negative 3. Okay? All right, you get an error. All right? Let's type in negative 2. You get negative 2. So 2 over, negative 2 down. And I'm going to type in negative 1. I get negative 1.3. I might find one more in here. So if I go 0, it ends up being negative 1. Oops, that wasn't right. Negative 2, 2. 1.3 was like here. 0, negative 1. I might keep going 1, 2, 3, 4, 5, 6. And then what ends up happening is it's 1, 2, 3, 4, 5, 6, 0. So this is what this looks like. Alright, I just kept typing in numbers until I got there. Now, labeling the arrows. The asymptote's over here, so that x-coordinate will be negative 3. This arrow's pointing down, negative infinity. Right arrow, going up. Zeros, it's going to be x equals 6. X equals 6. Okay? My y-intercept. Okay? Y-intercept is at negative 1. Vertical asymptote, x equals negative 3. Horizontal asymptote, none. This is increasing the whole way. All I care about are the x's from negative 3 to infinity. It's not decreasing at all. As x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches negative infinity. And as x approaches negative 3, y approaches negative infinity. All right, so pretty simple stuff. Domain. My smallest x value is negative 3. My biggest is infinity. So that's this situation where we're shaded this way. So that's going to become x is greater than negative 3. my range, my smallest y value is negative infinity, my biggest is positive. So the range will be all real numbers. Okay? All right? Write an equation where the exponential range is less than 2. There's all kinds of answers that you can have for that. All right? Here's what you have to have. All right? F of x. I'm going to use 3. I can use any number that I want. Is that would have to be a negative with a plus 2. Reason being, I would want to have some kind of anchor point with y as being 2. And this flips the graph, which will make that less than. Okay? 36, this is a review question, so make sure you do it. Okay? I would label this as -4, -2. To do the domain, also label this arrow infinity, infinity. My smallest x value is -4, biggest is infinity. So I have the x is greater than or equal to -4. For my range, it's -2 and infinity. So that's y is greater than or equal to -2. It crosses at -3. Those are the same. That crosses at 2. Okay, this is increasing the whole way from -4 to infinity. This is none. X approaches infinity, y approaches infinity. And x approaches infinity, negative infinity, that is none as well, because there's not one. Okay? So that is the new chapter. So one of the big things with that's new is graphing the logs in the calculator. Make sure you have the right shape. And make sure you go through that.